Well, this is where we were last time, right? Calculating the total charge. And we kind of broke the problem down into, well, we should find out how many kilometers they drove. We should find out what that means for the average. We should find out what that means for like how many above 100. And we're just breaking down the problem. And we've got like this if statement. If rental code is B, we do one thing, otherwise do another thing. So we're building up our solution. And okay, doing the total kilometers, well, that's just a difference. Why did I make this a function? Oh, we didn't have to, but I think it's nice because it makes it clear what this functionality is. Same with the average. There we go. And last time we also talked a little bit about like being careful where like the dependency is. It's often a little nicer if your function can get data and work with the data than having your function depend on another function existing in order for it to work. Both are fine, but there's advantages to one. And then this one. Well, this one, it's a simple function. Number of kilometers above average. Well, here, average number of kilometers. This was the whole thing, like how many above 100? If someone drove 90 kilometers a day on average, how many did they drive above 100 kilometers on average? 0, right? If they drove 101, how many above the average of 100? 1. If they drove 207, well, that'd be 107. Well, that's what's going on here. If the average number is greater than 100, return the average minus 100, right? Just get rid of the 100 baseline. Otherwise, return 0, right? I don't care how much under 100 they are, it's just 0. That's how many they drove above 100 to answer the question. If I were to do this a little differently, I think what I would do is I would change the 100 to be a constant because then I could give the value a name. Like I could call it like default allotment or something, right? So now the number 100, if I don't know what's going on, I look at 100, I go, well, what's that mean? Like what is that? Where if there was a named constant like default allowance, oh, okay, that's what they're allowed to do, and if they go above, like it just gives more context and information to the programmer than just a number 100. Yeah, okay. So if we go back, well, okay, total charge starts at 0. Total kilometers traveled, well, calculate the total kilometers with that function. Then average kilometers per day, do that. Then rental code is, okay, B, well then it's 20 times the number of days plus 30 cents times the number of kilometers traveled. And then similarly for the other one, it's $50 a day plus 30 cents times the number above average. That's a function call. Maybe I should have made these function calls or these expressions their own function. Totally could have done that. Arguably that'd be better. You know, give a name to it, like class B calculation or something. And then just effectively have that function run that one expression and return the value. But here I didn't. Why? Because. We could just talk about the different ways we can go about coding this. And remember, there's no right way. It's just, there's a lot of different ways. And then what do I have there? Okay, if the age is less than 25, just add 10 times number of days. But we see that funny little thing there on line 30, a plus equals. What the hell is that? Raise your hand if you've never seen that before. Really? Everyone else has seen it? Really? Let me ask again. Make sure you're waking up. Raise your hand if you've never seen plus equals before like that. Yeah, okay, that's a weird one. Well, we're going to talk about it very briefly, or very soon. But what that means is it's a shorthand for this number equals this number plus another number. What it means is take the total charge and add to total charge 10 times the number of days. So it would be like if I wrote total charge equals total charge plus 10 times number of days. It's a shorthand for that. I'll go into more detail on this very shortly. And then at the end, we return the total charge. Here's a couple of testing examples, being a little thorough there. And there we go. You know, there's nothing stopping us, though, like I have in that note, there's nothing stopping us from doing a little different. Why didn't I make the if statements their own function that could then calculate? Yeah, absolutely, cool. It doesn't, like, it's up to us. We get to design it. My decision making here was partially trying to be aware, okay, what makes the code clear? And also, I just want to get this done. So, you know, you're always kind of playing that game. And we've had a chance also to talk about the different ways we can go about implementing this stuff. None are right, none are really more right than others. We could start to talk about and argue about what's more better and whatnot, but at the end of the day, if it works, it works. We just want to make sure the code's good, too. As long as there's like method to our madness, we're happy. So how would you have done it differently? Like, having described it, did any of you think to yourself, yeah, I wouldn't have done it that way, I would have done it that way? And if so, like, well, what would you have done differently? Yeah.
I put them into two main if-else, if code is A, code is B. And then at the end, did the age.
Okay.
If it's at 10 times days and else is 0.
Cool. Awesome. Why that way? Do you think it's better that way, or did you just do it differently, or it's just kind of what came to mind?
Came to my head.
Yeah. That's often, too, what it comes down to. Is like, why'd you do it that way? Oh, it's the way I thought to do it. And it worked, so great. Yeah. How about anybody else do it any differently? All right. All right, loops. Well, raise your hand if you're done assignment 1. Perfect. Raise your hand if you're like almost done assignment 1. Cool. Yeah, well, usually we don't get to loops before the assignment is due. I like to leave a little bit of a mystery on assignment 1, but now you get a little spoiled because I moved the deadline till today, right? That 11:55, yeah. You're welcome. The only reason I did that again is when I said it, I didn't realize that Monday was, like, we didn't have class, or not class, but like regular school day. And although there's nothing against me having that deadline, I tend to not like to have it due on those types of days. In other words, though, don't expect deadlines to get moved back, though, right? Like, don't think this will, like, I want to make sure you're not thinking, oh, he's always going to push it. No. So, yeah, anyways. Okay, so loops. Fortunately, for assignment 1, you didn't really need to have a formal understanding of loops. We'll start talking about that today. But the whole idea of a loop is, I have a chunk of code I want to run again, and again, and again, and again, for some number of times. And I imagine a lot of you can think of the utility of why this would be helpful. But let's take a moment and think about it. Actually, before we think about it, let's realize, like, if and else, like, if is a great way to say, run this chunk of code if a condition is true. Some arbitrary condition is true. Run this chunk of code. But that code will only ever run once. And sometimes we need a block to run multiple times. Now, taking a step back, consider the following code, right? Take a moment, look at this, give yourselves 15 seconds, and think about what should be printed out as we go. Right? You don't have to yell it out loud or anything. Just come up in your head and see what will happen. And we'll do it together. A equals 5. So when I print out A, what do I get?
5.
Nice. And then B is 6. And then I print out A, what do I get?
5.
Who said 6? No one printed out B. We printed out A again. I tried to trick you. I gotcha. So B is 6, and then we print out A. Well, A is still 5. B was never changed. It's just B exists now. Great. All right, carrying on. Okay, A equals A plus B. Okay, so A is 5, B is 6. What's 5 plus 6?
11.
And where do we put it? Back into A. But A was just 5, right? What happened to that 5? It's gone. It's devoid of existence. Yeah, it's gone. Absolutely obliterated. No one cares about A anymore. Well, that 5 anymore at least. So when we print out A now, what do we see? 11. Great. And then we say, oh, A is 3. Well, what happened to the 11? It's gone. And that's fine. A is now 3. Great. And then we say A equals A plus 1. Well, okay. What's A? A is 3. What's 3 plus 1? 4. Where do we put the 4? What happened to the 3? It's gone. Yeah. So we print out A? 4. Great. Cool. So the point of this is, well, obviously it's review of variables and values and the literals and whatnot, right? But we can reassign values to variables. All that happens is that value just disappears, right? It gets overwritten. It's gone after we overwrite it. That's fine sometimes. Maybe we didn't want to do that, and if we made an accident, oh, oops. But generally, you know, it's fine to do. And also be aware, like on line 11 and on line 7, nothing is stopping us from using the variable we're about to assign to in the expression, right? When I said A equals A plus 1, well, I'm saying, okay, A, what value does A currently have? And then after all that calculation, pardon me, after all that calculation, we then overwrite A. Because remember, the assignment's the last thing that happens. I know I said it before, I'll say it again. Remember, the equals does not mean like a statement of fact. It's an assignment operator. It's not stating that A equals A plus 1, because otherwise I don't even know what that means. Right? When does A equal A plus 1? Does that even make sense? Right? So there we go. Now, I will say though too, never mind. We already talked about that. Don't want to distract you. So the point being emphasized is there's nothing stopping us from using variables, assigning a value to some variable, updating, changing the value stored in the variable. We're good to do that, whatever. Now, a very common pattern would be something like A equals A plus 1, right? That is a very common pattern. Maybe not even necessarily plus 1, but A equals A plus whatever, right? That's a very common pattern. Basically, update this value by some like relative term. Just make A 5 bigger, right? Make A 1 bigger. That's what that line is doing. This is such a common line of code, this type of thing, that we have a shorthand for it in Python and in many programming languages. And the shorthand is what we saw last time, the plus equals 1. A plus equals 1 literally means A equals A plus 1. It's a little bit of a shorthand. You might say shorthand, really? Because I've got like 1, 2, 3, 4 characters, and that's 1, 2, 3. Oh, we saved a character, not counting spaces. Yeah, you're right, but remember, A is a really shitty variable name. And really, we would want a variable name something like super right? Something like that, right? Well, you know, we just did plus equals, so much nicer, right? It's the shorthand. So, there we go. Here's a quick activity to make sure you're awake. Start with A equals 5. Figure out, well, you could probably already figure out what it does because we just talked about it, but figure out what that does. Figure out what that does. See if you can try any other operators and see what happens. Have fun. Go for it. I'll give you 1 minute for this one. Well, you did something wrong. You might want to restart your runtime. Say like runtime, restart session. Sometimes maybe you've accidentally reassigned something. All right, so what did a plus equals 2 do? Someone brave, come on. Crazy. It did nothing? Well, you're doing something wrong. So a equals 5, a plus equals 2, print a. These Python's happy with me.
I forgot to write print.
Ah, that'll do it, yeah. So you just had like this?
Yeah.
Well, yeah, you did, perfect. Cool, there. 7, why? Well, remember, a was 5, and then when we said a plus equals 2, that meant a equals a plus 2. Well, a was 5, 5 plus 2 is 7, and we put the 7 back into the a. There we go, a plus equals 2. Now what about times equals? Even before you hit run, did you have an idea what this might do? Yeah, a equals a times 2? Looks pretty good. What about minus equals? 3 makes sense. Divided? What the hell would that mean? Oh, interesting. So these do work as well. Did anyone try anything else to see if it would work?
Mod a equals true, and then a mod division equal 1.
Fascinating. Let's try that again. A equals true. And then this? Mod division. Well, that makes sense because true is 1. 1 mod 2 is 1. Mod equals 1. Okay, so you modded it by 1, so nothing should change. 0 though, 0. Yeah, because it would be remainder 0. Makes sense, yeah. Why? Good, that's a good reason. Like why? Oh, I wanted to see what would happen. There you go. In fact, good point. A lot of people, especially a lot of new programmers, always get freaked out about trying this. Like, what would happen if I hit run on this? I don't know. Run it. Tell me. I don't know. Probably not. Remember, here's the best part about this. Remember, we're running this code, not like your computer is not running this code. This code is being run on some computer somewhere else. So if the computer's going to blow up, it's not yours. So even if you did, it wouldn't be your problem. And at the end of the day, Google, it would be their fault. Because they let you do something you shouldn't have been able to do anyways. What about this? What do you think this will do? Why? Well, remember, plus equals is, plus is like concatenation of strings. So would that really do like a equals a plus world? Yeah, yeah. It did the concatenation of strings. That's nice. And then, of course, we all know what this would do, right? Nothing, because it makes no sense. But what about this? Oh, okay, yeah. Because remember, we can multiply strings, right? And all we did was multiply the string and then reassign the value. Cool. Anyone try anything else weird? I think you win, though. Doing true mod 1. Mod 1 is a weird one, because you're always going to get back 0, but whatever. Here, let's do that one more time, and I'm going to show you something fun. True, a mod 1, which is always going to be 0, but we're going to... well, it's false, of course. Right? Because 0, if you turn it into a Boolean, 0 will mean false. If I were to say, what is Bool of 0 is false. Bool of 1 is true. Bool of 2, what's that? It's still true. Anything that's not 0 is true as far as the computer's concerned. Anyways, cool. To be clear, if you're thinking, I got to remember this, no, that's weird, right? Like this is just a weird thing I'm showing you. It's trivia that if you become an experienced programmer, you'll be aware of, but like, I'm having a hard time seeing the utility of this right now. And if you are too, you're pretty normal. So any questions about any of that? This was just us screwing around with variables. All right. Now, while loops. Well, sometimes we have code that we want to run over and over and over, right? If we want to run the same code multiple times, up until now, what we've done is you just like repeat the same code multiple times. You just keep calling it over and over and over again. If I wanted to print hello world 5 times, I'd write hello world 5 times. The trouble with this is, 1, and mostly this is annoying. 2, it doesn't scale well. If I say 5 times, I'll do it 500 times. You go, ugh. Right, like this doesn't scale very well. It's prone to errors. Obviously this is simple, right? But if I make one error and then I end up copying and pasting it 500 times, I've got 500 errors. Ugh, that's a nightmare. It's not going to work if I say like, okay, repeat it n times. Well, what's n? Whatever I want to tell you. Like imagine caddis, right? Like I want to give you an input. Which input? N. So it's got to like work on a variable number of times. If I hard code print it 5 times, it's only ever going to do it 5 times. So this is where a while statement comes into play. It's just like an if statement, except it keeps going while the condition is true. All right? So if works, the code will run. You get to if your code's going and you get into an if statement, if the condition is true, you go inside and run the code, and then when you're done, you carry on. With a loop, it's the same idea. You go here till you get to the loop, and then you run it again. You run the code inside the loop, and then it goes back to this top, and it checks, is that statement still true? If it is, run it again. And it keeps checking, and it keeps running. And then, ideally, eventually that condition won't be true anymore, so it stops and then carries on. I'll show you examples of this. Right here. There. What did this loop do? I wanted to print out all the numbers between 0 and n exclusively. When I say exclusively, I mean up to but excluding the n value, right? And by the way, when I was saying like, oh, this like the previous example didn't scale well, this is what I mean by scaling well, right? If I want to make this run 1,000 times, I just do that. There, and it goes on, right? 10,000 times. There we go, cool.
What's the highest you can go?
You go pretty high, but do note that if you're like, it's really taking this computer that long to print out those numbers, it's taking that long to print out the numbers. If I told this to run without printing out the numbers, this loop would run like that. It's just that I/O, any input-output, is actually really painfully slow for the computer. So we could do this, and we could tell like the loop to run like forever. In fact, what's going to happen if I do this? It's going to run, well, let's see. That loop is going to run until the condition is false. Can that condition ever become false? No. So this is what we would call an infinite loop. It can't possibly stop. The computer's like, okay, well, true, all right. If you say so. Okay, I'm just going to stop it. Similarly, what would happen if I run this? Nothing. It's, well, false. Oh, I guess I don't run. That's it. False will always be false. True will always be true. What would happen here? if I hit run? Run forever. Why? Well, is 1 equal to 1? True. Who said yes? It's your one warning for today. So, if 1 equals 1, will 1 ever not equal 1? Yeah, that was really hedging your bets. Right? Yeah, so like, will 1 ever not be equal to 1? Well, I hope it doesn't ever change because, yeah. So even though I didn't explicitly write, well, true, I put in a statement that will always be calculated to be true. So you got to be careful with these loops because if you're not paying attention, you can end up with an infinite loop, which will happen to you, right? And by the way, if you ever end up into a situation with an infinite loop and you're like, ah, shit, I got an infinite loop. Like in Colab, you can hit the stop button. You could also press Control-C. Control-C will, I think. Maybe not. Never mind. I guess not. Thought it did. I guess I'm too used to terminal. Well, sometimes Control-C will work. But yeah, there we go. So there we go. That's a loop. Run this code until the condition is not true. Why did it work before? Well, what does the code say? Let's make this a more tractable number. Nope, not 100. Let's make it 5. Let's work through the code. Everybody pay attention. We're going to do it, and we're going to say it out loud. And if you think I'm making you say it out loud because I'm treating you like children, that's not what this is. Getting used to like saying and working through the code one step at a time is key to your success. So it's not that I'm being like, come on, kids, let's say these numbers. That's not the point, right? Even though I know we have fun with it, right? But still, it's very important that you do this. So counter is 0. What is counter? 0. So is 0 less than 5? Who said yeah? It was somebody over there. It wasn't you? Okay. Yeah, you have no clue. So, okay, that condition is true. So what do? Print out counter, and then counter plus equals 1. So if counter was 0, what is it now? 1. So we go up to the top and we say, hey, counter 1. Is 1 less than 5? True. What do? Print it out. What's 1 plus 1? 2. Okay, so we go back up to the line 2. Is 2 less than 5? All right, we print it out. Add 1 to it, it's 3. Is 3 less than 5? True. Print it out, add 1 to it. Is 4 less than 5? All right, print it out, add 1 to it, 5. Is 5 less than 5? We stop. But let me ask you something. What value does the variable 5 have, like, right now? After it's run.
5 is a literal.
Pardon?
I said 5 is a literal.
Well, it's still a variable, but what value does A have? It's,
We're being pedantic here. You're not asking counter, like the variable's name.
what did I just say?
You said what value does 5 have?
God
You said,
damn
what
it.
value does A have?
Yeah, you're absolutely right. What value does 5 have? 5, because it's goddamn 5. You're right. You're absolutely right. My apologies. Let's try that again. Maybe that's why you didn't answer, because I asked a bullshit question. What value does counter have? 5. Yes, yes. Why? Because it became 5, and then we said, hey, is counter 5 less than 5? No. Oh, so we stop. But A still did become, nope. Counter still did become 5. And we could prove that to ourselves by saying, but this 5 here was run after the fact. It didn't run from inside the loop. Any questions about what we see there? What's going to happen if I hit run on this? What's going to happen if I hit run on this? What about this? Why? Well, 0. 0 less than 5? Yeah, okay. Print it out. Add 10 to it. So we have 10. Is 10 less than 5? No. All right. There we go. What's going to happen if I do this? Or even better, what happens if I do this? How many zeros are going to get printed out?
Yes.
Yes. Yeah. All of them. This is going to run forever. Hey, is 0 less than 5? True. Print out 0. Is 0 less than 5? Still true. Print out 0. Forever. In fact, you laugh at this, but I'll have the last laugh because I know probably every single one of you will write a loop where you forget to increment your counter. So, haha. Just think back, oh, on October 1st, he said it would happen to me. Oh, there we go. Sometimes it gets mad. So if I run this, the same thing's going to happen, right? Counter, add 0 to it. Just print out a bunch of zeros. What about this one? What's going to happen? Count backwards forever. Because, hey, is negative 6 billion less than 5? Yeah. So there you go. Cool. Yes?
What happens if you were to switch the symbol from like less than 5 to greater than 5?
Oop, like this? And what do you want this to be? Plus equals still? Is that what you'd expect? Let's think about it. Counter is 0. Is 0 greater than 5?
False. If you change the 0 to like a 10, would it just go?
The 0 to here? Now it will go on forever. Yeah. Yeah. The reason it wouldn't have worked the first time when we had it like this was because counter 0 is not greater than 5, so the inside part never runs. And therefore, nothing could ever get incremented. So let's get that figured out. So 0 is 0 greater than 5, false. We never have a way to increment it, so it's just stuck at 0. What about this? Now, I'm being a little nasty. Yeah, I am. Assuming I wrote this correctly, there could be a bug in this code. I could be wrong. But before I hit run, but assuming this is correct, notwithstanding any little bug that hopefully is easy to fix, let me give me a sec to have a look at it. Okay. Yeah, I think it's correct. You all, based on what we've learned so far, you all 100% could get this correct. I would feel comfortable putting this on the test tomorrow. There's nothing new here. What does the code say? Take a moment, think about this. See if you can figure it out. Now, there's one thing in here that you might not know. Anyone want to guess what this means? It means tab in. It basically add some space. So add some space and then print out counter 2. That's what it means. Take a moment, think about it. You can figure it out. I hear Discord. Whoa, 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 whoa. Don't spoil it for anybody. Just wait a moment. We'll come back to you in just one moment. Who wants a hint? So, let me ask this. The outside loop, the one being like the furthest this way. How many times is that outside loop going to run? Well, 10 times. Why? Because counter 1 starts at 0. Well, counter 1 is less than 10. And then all the way at the bottom, we are incrementing counter 1. So it'll go for when counter 1 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the outside loop will run 10 times. Which means the inside loop is told to run 10 times. But how many times does the inside loop run its inside code? Okay, I'm going to hit run, and you're going to tell me if you're right or wrong, or more or less right or wrong. Oh, God damn it. What did I do wrong? Oh. There. Raise your hand if you were like, yeah, I was right. Awesome. Kind of. Other than what? If you were wrong, I'm betting you were trying too hard. You thought I was trying to trick you. I was playing a big joke. No. What did the code say? Well, let's follow the code. Counter 1 is 0. Well, counter 1 is less than 10. Well, that's true because it's 0. Counter 2 is 0. Okay, great. Counter 1, print it out. Well, it's 0. We see the 0. That's that first 0 right here. This 0 right here, this one, that's the first time this line runs. Then we go here and we say, hey, counter 2, are you less than 10? Well, we just said it's 0. So yeah, true. So what do? Indent and then print out counter 2. Well, it's 0. Increment counter 2, go back. Okay, it's 1 now. Print it out, increment it. It's 2 now. Print it out, increment it. Print it out, increment it. Da 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 da. Eventually we get to 8. Increment it 9. Is 9 less than 10? Yeah. Print it out, increment it. It's 10. Counter 2 is now 10. Is 10 less than 10? False. So one sec. So we've finished that loop. We exit. We go down here. Counter 1. Counter 1 was 0. It's now 1. So we go up here. Is 1 less than 10? Yeah. Counter 2. Start at 0 again. So basically, the inside loop is told to run 10 times. That's this, right here. It runs 10 times. But how many times did I tell that loop to run? 10 times. So if I'm doing something 10 times, how many things did I do in total? Let me say it again. I'm going to really emphasize these words. You know what? Let me change these values a bit, because maybe the fact that they're both 10 is tricky. Let's make this 5. So the inside loop runs 5 times. All right, so this is what we see. 0, 0, 1, 2, 3, 4, 5. 1, 0, 1, 2, 3, 4, 5. 2, 0, 1, 2, 3, 4, 5, and so on and so on and so on. So the inside loop right now is running 5 times. But how many times am I telling that inside loop to run in total? 10 times. So in total, if I'm doing something 5 times, 10 times 5 times 10, what do you get? Say 50, goddammit. 50, yay! You can do it, hey. Yeah, look, we counted to, well, 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3. If we do that a total of 10 times, that's a total of 50 times. So the inside loop is really running a total of like 50 times. But it's because we're telling it to run, okay, run the 5, and then repeat that 10 times. So 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, done. I threw you into the deep end with this. I want to be very clear. I did throw you into the deep end with this. However, there's no trick to what I just showed you other than what does the code say. Now, you had a question.
What happens if you like take away the /t?
The /t? Well, it'll become a lot harder to read. It'll go 0 here. It's just the indents are gone. 0, 0, 1, 2, 3, 4. 1, 0, 1, 2, 3, 4. 2, 0, 1, 2, 3, 4. The T just made it a little easier to see, kind of like in columns.
So say if you want like more than one indent, do you just put like multiple T's or?
It depends. There's a lot of ways we could do that. That is one way you could do it, but that's kind of a bit of a hacky kind of way to do it. There's cleaner ways, and we'll learn those soon. You got to multiply the tabs? And just make them just go, yeah. Times counter 2. No. Oh, right. Whoop.
I mean, that looks a little better.
Ooh, kind of. I guess it's kind of like, okay, 0, 1, 2, 3, 4, 1, 1, 2. Yeah, okay, interesting point. Now this should be really obvious, right? No, it's nonsense. It's to be clear, no human should look at this and be like, that makes sense. No, that's absolute nonsense. I mean, look, if I were to put this on the test, I won't. And we were like, what is it? Print out the output exactly as it would look. That would be sadistic. You could do it, but yeah, that's just mean. It's absurd. No one would do that. Of course, yeah, obviously. When you show up to a test and it's like, here's the special paper for the test, you're going to need it. Not a good sign.
I mean, kind of like if you like cut like paper on
You have to cut it sideways so that if you need to show up with a glue stick, yeah, not a good sign. All right, let's get back to it. Okay. So tracing through the function by hand. Well, okay, so what time is it? Let me make sure we're not running out of time. Perfect. So here's a tricky one. Trace through me by hand. Well, look, it's getting to the point where all of the code up until now, it was getting more and more challenging to just kind of keep all the values in your head as you went through the code. It was getting more and more challenging because our code was getting more and more complex. Now we are definitely at the point where if you try to keep track of this stuff in your head, you're not going to. Grab a sheet of paper, pencil, and just, chicken scratch the ideas down as you go to keep track of the values as you're going through your code. Otherwise, you're never going to get it. Any good computer scientist will always have a scrap piece of paper in front of them. If I'm in lab and you don't have a scrap piece of paper in front of you, you're a bad computer scientist. Get your scrap paper, and that's where you're going to jot your ideas down, right? Because remember, coding is the last thing you do. Getting the ideas in order, that's what you got to do. And that paper is very effective. And okay, it doesn't need to be literally paper. I see people with like iPads and whatnot. Cool, fine, whatever, right? But if you're trying to do it all in your head, I'm sorry, you're not that smart. It's not going to work for you. It's way too tricky. So if we were to go through this, well, here's an example. I'm saying trace through by hand. I've gotten a little table here. But I would kind of maybe create a table to be like, okay, what value is n and what is the result currently? How is that affecting, right? So when n is 4, okay, result is 1, right? And then when I go through here, okay, result, okay, I multiply it out, becomes 4. Then I decrease that, okay, so result becomes 3, or n becomes 3, and then what happens? So see kind of how I've got like a table, kind of like as the program executes, these are how the values are changing. You're going to want to have stuff like this down. This is how you get this stuff figured out. Trying to do it in your head, not going to work. You're definitely not doing yourself a favor if that's how you're doing it. All right. Being aware of the time, I'm not going to go do this one. This is where we'll start up tomorrow. No, not tomorrow. Oh, sad. This is where we'll start up on Friday, I suppose. Before we wrap up, though, does anyone have any final questions about the test tomorrow? Who can tell me where it is? Here. When is it? Whenever class is. Good answer, because I don't know. I just do it whenever my calendar tells me to show up. Okay, technically, as by policy, you should use pen. And the reason you should use pen is because it's like cheat proof. Because like if you get your test back, you can't change it, whatever. Don't be psycho. Don't use pen. That is a terrible idea because bring an eraser. You're going to want to do that. The way we hedge against this is it's really easy. When the tests are done, I'll post. I usually mark very quickly, except I won't be able to this year because I've got a billion meetings on the Wednesday and whatnot. So I'll get it marked as fast as I can. And I'll post the grades on Moodle, but I will never return the test to you. If you want to look at the test, come to office hours. I will very gladly go through it with you and whatnot, but to eliminate any potential issue of any fishy, funny business, you don't leave with the test. You could take pictures of your test. You can do anything you want, but you can't take the test. That's the one thing to note. Yeah, any questions though? Yes?
Is this stuff on it?
Maybe. Other questions? Yeah.
So you're saying we can use pencil?
Yeah. Technically, no. I know I'm on video too, right? So, yeah.
Will the stuff that's on the test kind of lower the amount of stuff that's on the midterm?
So say that again?
Like the stuff that's on the test, will that also be on the midterm?
Oh, everything is so accumulative. If you can't, at the end of the semester, if I were to be like, the stuff on the first test won't be on the final, that's not possible because you need variables and everything. So it is all accumulative. It's always going to be constructive. Your question? Speak up. Sorry? Theory questions? Like theory, like, can you be more specific? That's hard to answer without specific examples, but it's hard for me to answer that one. Yeah. Oh yeah, it's printed, ready to go. Yeah. I finished it this morning. Sorry? There will be some extra pages there for you, like at the back, and you can rip that off and take it with you. You shouldn't need any extra though, but anything beyond that. Yeah.
So we don't like, say if we don't have enough time to finish the test, are we allowed to like?
No. You have the allotted time. Last year, for example, like 80% of the class was done writing the test within half an hour. So everyone's different, and every test is different, but that's kind of what I target, right? I target to make it such that you have plenty of time to do it. Yeah?
Is it based more off of the lab questions in the textbook?
It's based off everything. Yeah. Explicit, like you will. That's hard to answer because I'm sure there is. Some of them, I don't look at the Kaddish problems as a template. That doesn't mean it's not possible that there exists a Kaddish problem that is basically the same question I have, just because by virtue of dumb luck. But I'm not basing it off Kaddish. I'm basing it off more like what we've been covering. Yeah, both in topic and lecture and or in labs and in the textbook and all that stuff. Yeah. Other questions? All right. I'll see y'all tomorrow, and you're going to be so happy, right?